Hi everyone, it's Mrs. Enders again. Going on to topic 6.3. You've done a couple little assignments and projects for this already, so your notes should be pretty easy to put together. So let's get going. So, we're going to talk about urban air pollution to start out with, and I've got some pictures here that show just how polluted some of the larger cities in the world are, and it's surprising how bad, especially during certain seasons, how bad the pollution can get. So, oops, we went one slide too far. Let's talk about urban air pollution. So, the United Nations Environmental Program, which is obviously part of the United Nations, has come out with some estimates, and they estimate that at least 1 billion people every year are exposed to some sort of outdoor air pollution. And they estimate that over 3 million people died prematurely this year, that they will die this year. Estimated 3 million people will die prematurely this year because of air pollution. Now, if we don't stop the pollution that we're doing and we don't do anything to curb it, they estimate that up to 9 million premature deaths from air pollution are going to occur in 2060, which is just a scary thought. That's 3 times what's happening now. Air pollution, they tell us, also has economic costs. In your lower economically developed countries, they lose about 5% of their GDP due to air pollution. This is everything from lower productivity to all sorts of agriculture costs and costs for healthcare. And for your countries that are more developed, they lose about 2% of GDP. So that can be quite a lot of money that these countries are using. Now, in your lower economically developed countries, 90% of the air pollution that's caused in these countries is caused by, surprising to me, I thought it was factories, but the United Nations Environmental Program estimates that it's poorly maintained, older motor vehicles that cause 90% of the air pollution. So, like I said, economic costs of air pollution are increased health care costs. And in most countries, a lot of these costs are borne by the government, which means that they're borne by the citizens, because the citizens and the businesses, the people who run these businesses, pay taxes, and this is what covers healthcare costs. There's also a decreased productivity of workers, because if they're sick due to air pollution, they cannot be productive at work. And also decreased agricultural yields, because when this pollution lands on plants, particularly particulates, plants cannot efficiently utilize photosynthesis. So, what are the types of air pollution? Well, 3 different types. Mostly when they talk about air pollution, we're talking about chemicals that pollute and particulates. But also biological materials can be pollutants as well. So most chemical air pollution is caused by the burning of fossil fuels like coal, gasoline, diesel. Coal is often burned for industrial uses and also at power plants. And obviously gasoline and diesel is mostly used in some sort of motor vehicle. Particulates are like little pieces of unburnt material. They're teeny weeny little pieces of whatever that hasn't been burned up. And AQI, air quality index, is the measurement of particulate pollution. And a lot of scientists and people follow AQI. When I lived in India, we followed it quite closely because if the AQI was above a certain point, which it was a lot, especially in the winter, fall and winter, the primary kids couldn't have outdoor recess. Um, Also, like I said, biological materials can be part of pollution. Things like pollen, mold, mildew, insect parts, fungus, and sometimes bacteria and viruses. Even animal dander, which is their skin scales. Um, so causes of pollution. Okay. We've got primary and secondary pollutants. You should pretty much know what those are because last week we really went over that quite a lot in our little project. Primary pollutants come into the atmosphere because they are emitted directly from a process. So if you are burning coal, the soot, the carbon dioxide, and other chemicals, those are primary pollutants. Secondary pollutants are formed when the primary pollutants undergo a chemical change or sometimes a photochemical change, which means um, in the presence of sunlight with chemicals that are already present in the atmosphere. So these primary pollutants are changed in a chemical reaction, and sometimes it occurs in the presence of sunlight. Okay, so we said that primary pollutants are formed from some sort of process. A lot of processes that we talk about is the burning of fossil fuels like in motor vehicles, electrical power plants, and all sorts of industrial processes. But don't forget, primary pollutants are also formed by forest fires, or crop burning, and also from volcanic eruptions. Sometimes these natural events can cause quite a lot of pollution in our atmosphere. Okay, so when we burn fossil fuels, some of the primary pollutants that are produced are carbon monoxide, carbon dioxide, particulates, which are these unburned pieces of hydrocarbons. Hydrocarbons are chemicals that, wow, can't believe that came up, are chemicals that are made of only carbon and hydrogen. There's nitrogen oxides, sulfur dioxide, and soot, which is a special kind of particulate. Now, carbon monoxide and carbon dioxide are greenhouse gases. Carbon monoxide is also that chemical that it reduces how much oxygen is circulated by the blood. And if you get too much carbon monoxide into your system, you can suffocate. Nitrogen oxides are several different chemicals: nitrogen dioxide, nitrous oxide, and nitric oxide. These are the chemicals, the primary pollutants that react very heavily in sunlight to produce the secondary pollutants. Same thing with sulfur dioxide. You find sulfur dioxide released as a pollutant because the coal that's being burned has a real high sulfur content. And it also reacts with chemicals in the atmosphere to produce secondary pollutants. And soot is not something, and also other unburned hydrocarbon particulates. These are things you don't want in your lungs. They can cause lung disease and cancers. So, we also have to talk about the bad ozone. We talked about ozone formation in the last topic and the good ozone that's in the stratosphere. But when the ozone's in the troposphere, when it's closer to the Earth, it's considered very bad ozone. It isn't a lot of the ozone that's in our atmosphere, only about 10%, but when it is in the troposphere, it is another greenhouse gas. It increases global warming much more, over 2,000 times more than carbon dioxide does. And it also damages plants, and it affects human health. So plants end up absorbing it into the leaves, and it destroys the chlorophyll in the leaves. So your photosynthesis is much less effective. And then you have lowered crop yields. Ozone causes breathing difficulties in humans. It lowers lung productivity. It also lowers the effectiveness of people's immune system, so you end up getting many more infections, and it's very irritating to the eyes, the nose, and the throat. Ozone in the troposphere also affects materials and products. It's very hard on natural rubber, cellulose, and plastics, which are used in all sorts of packaging materials and other industrial processes. Things like O-rings and seals and things like that, which will make the products that have these rubber and cellulose and plastics in them to last not as long as they should. Ozone also bleaches fabrics over a long term, and significantly reduces the lifetime of car tires because they're made out of rubber. So how do we produce ozone? It's produced in hot car engines, and the nitrogen and the oxygen in the atmosphere chemically react to form the various nitrogen oxides during combustion. And then the nitric oxide reacts with O2 in the atmosphere to form nitrogen dioxide. And this nitrogen dioxide, it's a brown colored gas. So that's why often urban haze looks brown. So then when it's sunny, the nitrogen dioxide breaks down into nitric oxide, which is a smog product, and oxygen, just a single oxygen atom. And these atoms of oxygen then combine with oxygen molecules, which is O2, to form ozone. I know it's kind of a lot of chemistry here, but it's important to kind of point out what the process is. So here is kind of without all the chemical symbols and all that kind of stuff, which is not important. I've got a diagram here of exactly what I just talked about, where you have the nitrogen and oxygen in the atmosphere going through the whole process and ending up as ozone. Now this is where I'm going to stop with part 1, and we will move on to part 2. Thank you very much for your time. I hope this narrated video is helpful to you.